Hello, hello. My name is. I'm too eager, aren't I? So yeah, my name is Mike. I'm probably many things. One thing I'm not is affiliated with the project I'm going to be talking about, but I am a very enthusiastic user. So it's not my project, but the enthusiasm is my own. So in my job, I sift through moderate quantities of disparate data, and I use spreadsheets, and I run them mostly in the terminal. Now, why? What the F am I thinking, right? Why would I do such thing? Well, laziness. That's a very good reason to do anything. You get very far in life with laziness, I found out. And impatience. If you ever saw my poor abused mouse, the human interface kind, not a rodent, uh, it's abused because when things are not loading, I'm basically doing this, right? So if I could use GUI spreadsheets. They are fantastic. I don't want to, diss them. They are amazing. They enable people to do myriad things, but they also require me constantly changing between the home row and the rodent and back and forth, back and forth. They tend to be slow to load. If you have like 200,000 rows, 200 columns, and you want to filter the thing, things can get a bit lengthy. And then there are the formulas. For goodness sake, we have Python. Why do we need to use that? I am okay with Python. I do a lot of data wrangling with Python. I don't like spreadsheet formulas. So that all kind of spells for me a big trouble with GUI spreadsheets. Luckily, there is an alternative. There is a project that has Python for formulas or uses Python for formulas. You can move around and do anything with your fingers comfortably on the home row using Vim shortcuts to move around. Those are the best shortcuts, as everybody knows, and it's fast. So that project is called Visidata. It's a play on words. There was a spreadsheet once called VisiCalc, and this is now Visidata. I know VisiCalc for the age of data, I'd imagine. The creator describes it as a multi-tool for data work. So if you ever looked at a Swiss Army knife and thought to yourself, I wish my spreadsheet was like that, that's what Visidata is. So I have to go through this very quickly because I have only 2 minutes left. So this is when you start with the data spreadsheet with that command. This is what you see mostly. You have columns, you have rows. One of the rows is selected. And one of the columns is selected. You can clearly see it. You can move it out with HJKL, or you can use mouse, the arrows. And you can also use the mouse if you wanted to. If you, for example, from this want to see what columns you have, so it will give you some metadata. It will show you the data that's selected for the row, and you can use, for example, that width column with a simple shortcut to set in bulk the width or even completely hide the columns. If you, for example, from this screen wanted to see how many different reviews there are. Oh, I think I'm lost in this now. Right. Well, anyway, so if you wanted to see how many different review categories there are from the spreadsheet, you just press a single F on the selected column and it will give you a histogram and a frequency table. If you wanted to do this in Excel, you probably need to spend about a minute clicking around, inserting a pivot table, but this is just a single keystroke. And that's basically what Visidata is all about. Another amazing thing about Visidata, and Excel doesn't do that, is you can use regular expressions. I know people don't like them, but they are amazing. Let's say that you have that column with prices, but somebody helpfully added the dollar signs, and you want to get rid of the dollar signs because you can't add strings. So you can just type a semicolon and then your regular expression. It will create a new column with just dots and digits, or any other regular expression will work. It's all Python regex. Thank you very much.
I'm already connected. Hello, everyone. So, I need to find out the end of these super cool things. Right. So, and my time is started. Hello, community. Hi, team. I'm Alex from Canonical Data Team. And today we'll talk about charm of MySQL. Now it's important. The following video will be highly compressed in time. So stay with me at least on the beginning before falling asleep. And let the party begin. I hope the font is good enough. So the goal is to deploy database in Kubernetes. What can be easier, right? Just type my command, juju deploy MySQL, and in a couple of seconds, literally 10 here, but 2 minutes in reality, you have database running in Kubernetes. Nice. Let's use it. Let's, for example, create our own super pooper website, deploy it, integrate with MySQL, and now they are exchanging data and can store database, WordPress can store database inside. Additionally, we dropped ingress in front of WordPress to have access, and waiting a couple of seconds more to deploy. As you can see, database is being initialized, WordPress is already happy, and above we are requesting the credentials to access our web interface. The last piece is getting IP from ingress, and we have one. So we have credentials, we have IP address, let's try it. We open in browser, voila, we have a WordPress, it's running. We have a data which is stored in database. Let's start filling our super pooper website. Let's go to admin interface, we're using credential, that works. That's surprise, but that's good. Going inside, changing the data, let's put something really truly superb, like charm with MySQL is super. Let's don't forget about Juju. Juju is the best. Save that. Let's go to web interface. Let's see that that really works. And voila, that works. Let's drop it in the corner. And wow, we have website. What should we do next? We need to care about our data. Let's backup that scenes, right? So let's drop S3 integrator. It's a tool which helps database to store all the data in all the compatible S3 storage. In this case, we deploy it on Amazon, but it can be Ceph behind Rados gateway, whatever you want. And we integrated it with MySQL. So they exchange, and MySQL immediately have access to the storage. For example, there is already some database backup stored. Let's create another one with our super data, right? And it's done, slightly speed up. We have lightning talk. And as soon as this thing's over, you see the last item is just recently created one. We need to damage our data. What can be more funny, right? So open a website, again, go into admin interface, and changing our data. Oops, data has gone. Oops. Saved, checking that it's gone. You see in the corner, its data is gone. Drop it again in the corner, and let's restore our data, right? What can be easier? Just one command, juju restore backup ID, specifying ID we just created recently. Couple of seconds gone. What we need to check that database is gone from WordPress, database restored, data restored. As simple as that. Wow, what can be simpler, right? Couple comments. But that's not all. That's great, our site became popular. What should we do the next? Let's scale our database, let's scale our website. So it's as simple as Juju scale application, specifying what you want, how big you want, and the Juju start doing magic for you. Meanwhile, what is more important, your website is fully functional, so you can scale up or scale down to save your money whenever you want, and no one will notice that. Wow, that's cool. Juju is doing some magic. You see some peers are joining the cluster. Data is copied over all of them. That's all Juju magic. We need to wait a couple more seconds until all the tools are active, happy, and this is that moment. Right, so we're going further. Great, while we're working on that, the big CV has been released, 0-day vulnerability. We need to fix that. How to do that? As simple as run juju refresh, specifying where you want to jump, and checking pre-upgrade check before to make sure that your database is okay, your cluster is okay, make some tuning to make the upgrade better, or block it if it's not compatible. And what we did, we upgraded the only one unit and give you a chance to test it as a sacrificial unit. And if you like it, continue upgrade using resume upgrade. If you don't like it, you can roll back, you can stay in that position to test it a bit longer, etc. More options are in documentation, but what we did, we resume upgrade, and you can see it start propagating for other units, and website is still reachable, but that all running on my laptop. By the way, framework, thank you for the superb hardware. I'm loving it. And you see, we reached the moment when switchover faced a cluster down. That's not a problem. Juju will detect that. You see WordPress on the bottom start dealing, and it will automatically fix that things. Super. Can that all be done without downtimes? Sure. Just deploy MySQL router, integrate it properly, using examples before. But we are online team talks, 5 minutes only. And we are jumping. We'll learn today a couple of commands. You can use all of them for databases above, deploying them on the all appliances below. And there are way more on Charm Hub. So please check the list there and see you there.
Amazing. Thank you. Do you want the clicker? You don't want the clicker.
Okay. Hi, everybody. My name's Laurenz from Typest. And to start off, I would like to ask the developers among you, or silently ask yourselves, don't please respond, but about how do your editing cycles look like? So for me, it's basically edit, run, and then look what the results are. I'm maybe inspecting this with my editor on the left side. The font embedding completely failed here, probably because I did this presentation with our homegrown software. Anyway, so I print the results, and then I run on the right-hand side my script. And yeah, but basically, always running the script again and again is a hassle for me. I really only care about the behavior of my program. I don't want to run it. I just want to see how it behaves. And the goal here today is to find out how can we have a live view of program's behavior without running it ourselves. Ideally, by having the computer figure out what's changed without actually rerunning the computer program from scratch. And the solution is to remember things that didn't change. So let's look at the simple example. Okay, this looks terrible. You can see what's going on. We have a recursive function. It runs in exponential time because we're calling fib twice. But actually, for fixed n, this function always returns the same value. So we can simply, whenever we call fib for the first time with a specific n, we can just store that in some data structure. And then when we reach that n again, just look it up. And by this simple trick, we gain linear time for this algorithm. And yeah, but this only works because fib is a pure function. That means it does not have side effects. It does not read global variables, write global variables, God forbid, open a socket or something. So that's a restriction I'm going to put on the scripting language we're talking about today, but it's a quite sane one for lots of algorithmic tasks. So are we done? Just memorize stuff and somehow do things incrementally? Unfortunately, it's not quite that simple, because think about what else happens while you code. Quite often, the code is changing. So if we add something into this function, its result also changes, but we still want to have some way to remember the results. And what even worse would be if we have this function that reads a file. Now, imagine a file changing your system affects this behavior, the behavior of this function. So in the end, whenever anything on your system changes, any file changes, potentially the results we cached are invalidated. So the whole program, your whole program is input to a memorization, the whole hard disk state. Basically anything can change anything. So let's not even talk about what happens if this function throws an error. And this is the problem we faced at Types. And we solved this with a technique we call constrained memorization, where we add an additional type of input to functions, a tracked input. And for this input, we observe at runtime what parts of it were observed. So going back to the file system example, if a function does not read any files, then we generate no constraints on the file system, so any file system is fine. But if the function reads 1.txt, then we generate a constraint that says 1.txt needs to have this specific checksum for our memorization to be valid. And in this way, we can basically memorize stuff while a lot of stuff is changing, and only if something affected a function, we have to throw away the memorized results. And I could talk a lot more about this, but as you all know, I have 5 minutes, so let's instead talk about the cool things we can do with this. For example, we can have these cool hover tooltips, where when we hover over a variable, so the cursor used to be above val, then we can see val takes on the values 0, 4, 8, and 12. You can also hover over the for loop and see it produces the string 0 and 4 and 8 and 12 end. And the same thing applied to auto-completion is seen here. We have code that at runtime decodes a string written in YAML, and the auto-completion picks up on the string, the strings in the, so the keys in the string and the values in the string completely dynamically. There's no type hints or anything. And of course, we could also do this without the incremental part, just running the code over and over again and observing the values. But the cool part is that incremental execution makes this so cheap that we can actually do it for IDE tooling. And yeah, so how did we get here? I did this for types. We built the system because types is a modern LaTeX alternative that aims to provide incremental preview of your documents. And as it happens, it also has a full integrated scripting language. So we kind of were stuck with having to deal with this. How do we increment these, evaluate these incrementally? And that's why we built this system. And yeah, that's it.
Mike. Okay, thank you.
Yeah, so I'm Rich from the .NET team at Microsoft. And so we're kind of like a new entrant in the Ubuntu community. Our product was added to Ubuntu in 2204. And so that's been really exciting for us. And so our next version is going to be shipping, I think, next week on the 14th, and it will soon be available in Ubuntu. Okay, and we've also been working on chiseled container images with the fine folks at Canonical, and those are GA this month. Okay, so this is just like 4 or 5 slides about what we've been working on. So we're super big into performance. So you can see each release we've put even more effort into performance. So we have apparently 1,250 improvements related to performance in this release, and all of our releases are 1 year. Like that's how long we work on them. We have this third-party performance benchmark that we work against called Tech Empower. They're basically benchmarks from like tons of different programming languages. And we've put a lot of effort into this over the past almost 10 years. And so one of the benchmarks is called JSON, another one's called Fortunes. And yeah, you can see that .NET has continued to get better, and you can see some programming languages are less good at this. So .NET works on both the client and the server, but these days we're super focused on the cloud. You might know that Microsoft happens to own a cloud, so that's part of our motivation there. So one of the things, I'll just focus on 2 things from this slide. We added a non-root user to all of our container images, to our entire fleet. And so it means that we wanted to make it a 1-line change for any .NET developer who builds containers to make them non-root. And our goal is to make .NET among the most secure, basically container platforms in the industry. And then the other thing that we did was worked with Canonical on chiseled images and make those super small and have very few components in them so that they're easy to maintain over time. Okay, very related to that, we have been working on making our container images like way smaller. So I'll just basically talk about the start and the end of the journey. So if you like basically take your app and do nothing to it and just deploy it on regular jamming, your container image compressed will be 86 megabytes. So that might be more than that you want. On the complete other end of the spectrum, we have some tools that you can use to trim your apps down. And we also have native AOT. What that does is it compiles your app to native code, and the runtime we use for that is quite a bit smaller. And so if you basically put all of these tools together, your app goes from 86 megabytes down to 8. So that's basically 1/10. You're more than capable of doing the math. So we're pretty excited about that. This is new, and we think a lot of developers will be interested in that. And so before we had native AOT, basically these were our numbers for our product on both Linux and Windows. We're super big into Linux. And this is our numbers after. So you can see that we've kept the rightmost numbers pretty high, which is requests per second. That's all good. But all the other numbers are way lower. And you can see, other than one of the numbers, I think, but yeah, basically you can see the Linux numbers are really excellent, particularly for startup. And that's it. So I made it with 20 seconds to go. Anyway.